Second, just to present you who is the team dedicated. Not sure you see my slides.
Yeah, I can confirm I see the slides.
Put it in full screen, maybe. Voilà. So I see that I heard that Elias maybe is in the call.
Yes, I am.
You want to introduce yourself, please?
Of course, yes. So my name is Elias Komsi. As you can see, I'm the business unit manager of Data and AI. We cover about 10 brands in the unit, and Nvidia is one of the 10 brands. So I've been with Taro for 5 years, and I think that for now 2 years we are very successful with Nvidia. We've done multiple things already, both in the vGPU side and also on the AI side. So yeah, that's it for me.
Thank you, yes. My name is Julien Dalliot. Some of you know me or have you seen mail from my side. So I'm in charge of few of the brands in the business unit and also in charge of the development of Nvidia for the Belux market. Basically, I'm working since 6 years almost at Arrow, and I'm more dedicated at technical business development than just sales business development. Lorenz?
Yes, thank you, Julien. Hi, everyone. My name is Laurens de Munter. I'm a colleague of Julien. I'm also a BDM in the Data and AI team, also handling Nvidia amongst other brands. And I handle more the commercial part. So everything that's quotation request or requesting in regards to licensing will probably be picked up by myself. Thank you.
Thank you, Laurent. Beside our team, we have also Verle Fong. She is in charge of the partner development manager. So some of you have contact with her, I presume, and she's managing a team of 3 field development manager, one based in Luxembourg. Actually, there are 2 based in Luxembourg and 2 based in Belgium. You also have Gaetan Kombe, which is the data and AI team leader. He's in charge of all the back office load for our department. And Eric?
Yes, hi everyone. I'm Eric Toussaint. At Arrow since 3 years now, and responsible of all marketing activities for Nvidia and also about 20 other vendors at Arrow.
Thank you, Eric. Not sure Agata is there. Agata is in charge, as you see in the slide, distribution sales managers. So she's in charge of the district, so Arrow, actually. She's based in the UK, but she will not join us today, I think. Jits?
Yeah, my name is Jits Langendijk. I'm a solutions architect at Nvidia, focusing on channel enablement.
Thank you. And then we have Chris. Chris is in the call.
No, I don't see him, but I forwarded the call just as a reminder to him. So maybe he will be joining us later on. But
so Chris actually is working beside of us. We work together in terms of partner development. So actually, you have two line of contact, of sales contact or development contact, which is Nvidia via Chris for the sales part, development part, and Arrow. And you see there is a quite important team as Nvidia is one of our, how to say that, most important brands in our division. Yet, be my guest.
Yes, thank you very much, Julian. And let me see if I can share my screen. See, I think it's this one. Okay, it says an unknown error from my side, but not really sure whether. Oh no, I think you can see my my slides, right?
Yeah.
Yeah. Okay. Yeah. So I already introduced myself, but here is also my email address. So the important part here is on this slide. Whenever you have any questions, always feel free to reach out. I'm happy to support you with any problem, project, opportunity, or anything NVIDIA related, feel free to reach out about that. Let me, yeah. So for today, I have a couple of things on the agenda. As I always mention, when I prepare for such meetings as this, I browse to everything that we have available, and this is like me going through a candy store. So usually I end up with too much information, but always feel free to reach out afterwards if you have any specific questions or just want to have a follow-up on a particular topic. So today I'll do a very brief introduction on NVIDIA. We'll be talking about hardware and the options that we have here, a short NVIDIA vGPU update, and also Omniverse CloudXR will be mentioned. So feel free to ask any questions in the chat. I will try to monitor that as well. And one thing that I want to remind you of is our NVIDIA GTC, our annual event, which will be taking place or will start at April 12th. And I welcome you all to register for this event and browse the session catalog, because there's a lot of useful and valuable information. And I'll share the links afterwards as well. Also, at the end, we'll do a short pop quiz with some prizes, of course. So, pay attention, and just a fun exercise at the end for in order to get some prizes. So, a brief introduction on NVIDIA, who we are. I think the majority of Aero partners and NVIDIA partners, of course, they perfectly are aware of what we are. But we are, the computing platform company, so we will be focusing on the entire scope of the entire platform, and the majority, of course, is all with acceleration. Whether it's for visualization, getting a pixel on a screen, or whether it's high-performance computing, doing calculations, mathematical calculations, or whether it's artificial intelligence. As Elias also mentioned at the beginning, together with Aero, lots of partners already are indulged with the beautiful things that can be achieved with artificial intelligence, and NVIDIA together with Aero can help you, of course, get the right equipment or licenses in order to get started with artificial intelligence. Of course, many organizations, and although my next topic is about hardware, many organizations today, it's still more or less focusing towards the software-defined stack, of course. But for us, it's a little bit a combination of both, of course. Great hardware, this is the foundation of our organization, whether it's an embedded solution, whether it's a DGX, or anything in between, or whether it's the high bandwidth, low latency, InfiniBand and Ethernet solutions that we have together with Mellanox or NVIDIA networking. And on top of that, for different focus areas, whether it's workstation servers or cloud, whether it's visualization, HPC, or AI, we have different layers of software solutions. And of course, the Doka for our Mellanox solutions, for the Bluefield or the SmartNICs, the Connect X6, or whether it's CUDA for our GPUs, we share one common architecture across the entire stack, whether it's GPU or data processing unit. And of course, a very important layer between, or the second one from the top is all our software SDKs that we have available. And the majority of those is free of charge, such as Metropolis, Intelligent Video Analytics, or Isaac, robotics simulation. And of course, as many existing partners today focusing on virtualization and GPU virtualization, the vGPU solution is a common solution that we provide together with Aero and you as a partner, of course. So our enterprise portfolio can be categorized into 6 main areas. And this is our enterprise portfolio. So GeForce or automotive is a little bit, outside of this scope. But of course, we have our RTX, formerly known as Quadro boards. These are the actively cooled GPUs for your workstation or mobile workstation. We have the data center solutions, the GPUs optimized for being used in the data center. Most of the time, these are passively cooled GPUs, because in the server you have a different airflow, of course. These boards were kind of categorized in the past as being a Tesla board. we've got lots and lots of software. We can spend an hour on just all the SDKs that are available there. And of course, vGPU, virtualization is an important one there. We have our DGX systems, the purpose-built appliances for deep learning training, mainly focusing on training, although now with the DGX A100, you could also mix and match like training and inferencing on the same physical GPU or the same physical box, of course. So the A100 provides more flexibility due to the multi-instance GPU technology that we provide with this latest GPU. And as mentioned, a lot of embedded solutions, whether that's the Jetson Nano, or the Xavier. But these are usually more used, or you can find those in like purpose-built solutions, like robotics, for example, or maybe autonomous driving. And of course, networking. With the acquisition of Mellanox, we are now focusing on not only supercharging the brain of the computer, so a GPU next to the CPU, but also feeding this brain with all the network that is taking place there. So high bandwidth, low latency, InfiniBand. This is what we can do together with NVIDIA networking, of course. And as I mentioned a little bit about the hardware, throughout the years, we have developed various GPU architectures, and the latest architecture is the Ampere architecture. And there's one thing that we need to keep in mind with GPU architectures in general, but especially also with the A100. As a GPU, as I said, can be used for visualization, getting a pixel on the screen, or it can be used for computational acceleration, like weather forecasting or strength calculations of a building, for example, or calculating how fire protecting a wall is in a building, for example. And with in the pre-Pascal version, so with Maxwell, you had to choose either to use a GPU for computational acceleration or for graphical acceleration. And maybe for those who remember the M60, there you had a change mode utility where you can change between compute and graphics. But with the introduction of Pascal, this is gone away. So now you can use a board for compute and graphics simultaneously. However, there are boards that are more specifically designed or better suitable for a compute task or a graphics task. So with Volta, the V100, you would see this is more like a HPC, AI, machine learning, deep learning type GPU, and especially the double precision, which is important for high performance computing, as where the Turing boards, the T4, for example, in a server, is more focusing on graphics with its real-time ray tracing, for example. So now our latest GPU architecture, the Ampere architecture, we started with the introduction of the A100. And the A100 is the board that we are using in the DGX A100, for example, but it's also available with as a PCI Express device. However, this board doesn't contain any graphics acceleration. Yes, it can do graphics acceleration, but it's far from ideal. And also specifically for those who are familiar with a VDI environment and with graphics acceleration for VDI, you would really benefit from the encoding capabilities, because all the remoted frames from your server need to be sent over to a client device. And this requires encoding whenever you're using a video codec. And the A100 doesn't have any encoding capabilities, only decoding capabilities. So that's why the A100 isn't really suitable for a virtual PC, a vApps, or a RTX virtual workstation, formerly known as the Quadro virtual data center workstation license. So if you want to do AI on a vGPU solution, just with virtual compute server, the A100 is good to go. However, if you want to do graphics acceleration for your typical VDI deployment, the Nvidia A40 is the best board to choose there. And we also have the Rtx A6000, but the Rtx A6000 and the A40 are more or less the same boards. Yes, the Rtx A6000, due to the fact that it's an actively cooled board, has a slightly higher performance. However, the Rtx A6000 is specifically designed to be used in a workstation or mobile workstation scenario, is where the A40 is specifically being developed for being used in a data center solution, so in a server. So for those of you who've seen sessions like this before, you might be recognizing this slide, but we see all the different GPU architectures being Ampere the latest, and a GPU can be either more specifically designed for being used in a physical environment, so a workstation or a laptop, or a data center solution, so in a server. So we have a huge lineup of GPUs, whether those are for the workstations or the mobile workstations or the data centers, and the biggest difference there is primarily the cooling, of course, actively cooled versus passively cooled. There is, however, one thing very important and to keep in mind with the data center GPUs. So initially, a data center GPU was being used for like high performance computing or AI type workloads, and not so much about graphics acceleration, because a server in the data center, no one is going to connect a physical display to a server in the data center. Maybe an administrator, of course, to troubleshoot, but in a day-to-day work, that's nothing you would do. So the GPUs for the data center were specifically designed in what we call the Tesla compute cluster mode. So there's not really graphics being involved. So, but when we started to use those data center GPUs for GPU acceleration in the data center for VDI, we had to develop something different. And this was in 2013, the Nvidia Grid solution, where we changed the driver set for the virtual machines in the data center in order to unlock this graphics acceleration for Windows. So this is why you always need a vGPU license for a data center type board. So I've tried to create a little bit a layered approach on well, starting from the hardware, of course, and whether you do like virtualization or you do bare metal, and it's more about what is the use case that you're trying to fulfill? Is this just high performance computing, bare metal, or pass through? Well, then you just need a GPU with a driver that is working in the TCC mode. Nothing going wrong there. However, as soon as you start using a GPU, a data center GPU for graphics acceleration, then all of a sudden the vGPU license is very important. So keep that in mind. And again, this doesn't really matter whether it's Windows or whether it's Python or anything in between. As soon as you're using a Windows device or Linux device and you want to do graphics acceleration, you would need a vGPU license. So a little bit back to the different two GPUs. And one thing that I forgot to mention, of course, is that Arrow, our strategic distribution partner, global partner, but also, of course, in Belgium and Luxembourg. It's not that in our entire portfolio, they are capable of both delivering the RTX, so the Quadro boards, the Tesla or the data center boards, the DGXs, and also the networking part. So you got your one-stop shop whenever it comes to Nvidia. So this is also the reason why we now will cover also the desktop and the mobile workstation GPUs, because this is something that, in the past wasn't part of the portfolio together with Arrow. So if we talk about the RTX, formerly known as the Quadro, so we did a little bit of rebranding there. So the Quadro name will be fading away and will be replaced by Nvidia RTX. And yes, this can be sometimes confusing when we're talking about GeForce RTX, the consumer products. But with the Nvidia RTX, we are focusing on the professional designers, those people who are working with the application that really require the Quadro features, the RTX features as we call them today. So they are rendering this complex and high quality images, for example. They're using applications that, although you do not see this right from the start, but are using AI in order to optimize an image for a designer. And they are using applications like ANSYS Fluid Dynamics, where you both need to do the computation of how fluids or gases, in this particular example on the left lower picture, how fluids or gas, sorry, how they behave in a tube, and if you starting to compress them, what kind of result would that give? So this is just purely compute, but also visualization, so compute and graphics simultaneously. and of course, virtual reality or mixed reality, any form of reality, extended reality, as we call it these days. Very important, and we see this in various use cases, in various verticals throughout Luxembourg and Belgium and across the globe, effectively. Whether it's manufacturing or data science, simulation, etc. The RTX capabilities that the GPU can deliver in a mobile workstation or in a physical workstation is really, well, the key to success for many organizations. So today, what we have available, this is based on the Turing architecture. So we got the RTX 8, 6, 5, and 4000 GPUs available, which can be used in a physical workstation. For the mobile workstations, we have the 6, 5, 4, and the 3000 RTX GPUs available. So these are specifically designed for the workstations that you can buy with our partners. And of course, based on our latest architecture, that's the Rtx A6000. So that's the latest and greatest when it comes to GPU acceleration in your physical workstation. Actively cooled board, 48 gigabytes of GDDR6 memory. Well, effectively, there's nothing that can beat this today. So the entire lineup today of the RTX brand, the actively cooled boards, is, as you can see here on this picture, the Rtx A6000, Rtx 8, 6, 5, and 4000, and also for the mobile GPUs, the 6 to the 3000 GPUs. There is one thing that I want to highlight here, and also maybe, well, is kind of a segue into the data center GPUs. What we see is with many of our OEM partners, we have developed like a data science or RTX server type configuration. So for those organizations that rely on RTX capabilities, but do need to centralize their resources into a consolidated, maybe virtualized environment, an RTX server is a great solution to that. And the reason why RTX, or formerly known as Quadro, is that important is primarily due to the fact that we have a huge list of applications that are being certified on what used to be called then Quadro, and today what we call RTX. So for those organizations that rely on this Quadro certification or RTX certification, this really helps them. And of course, we also are capable of delivering this in a data center solution as well. Talking about the data center and cloud solutions, so the data center GPUs are also being used by many of our cloud partners, the hyperscalers, of course, whether that's Microsoft Azure, Google Cloud Platform, or AWS. And some have some older GPUs like K80s today still are available in Azure, but T4s are also becoming more available in various regions of Azure. And the same applies to AWS and GCP. But the lineup of GPUs today for your data center, your private cloud environment, or your customer's environment, of course, or a hyperscaler is based on the Turing architecture, the T4. So the T4 will be a long-lasting GPU that will be available for the upcoming years. At least that's the latest that I understood. And of course, make sure to catch the keynote at GTC, April 12th, to see which kind of new GPUs will be announced based on the Ampere architecture. But the T4 won't be gone very fast. Nevertheless, it's not going to be replaced in the upcoming years. But of course, on the Ampere architecture, we have the A40 and also still, of course, the RTX 6 and 8000 passive GPUs. And also the A100 and also the A100 80 gigs, but this is only available in the SXM form factor. I put in this slide as a reference, so which GPU to choose in which configuration. I'll make sure that you get your hands on this deck, so you can always have this as a reference for yourself. But always feel free to reach out if you want to do a double check. For the next topic, and I'm just peeking at the chat, so feel free again if you have something, put it in the chat. Happy to address that. So with the data center GPUs, one thing that we do is, of course, making GPU acceleration for virtualization and for graphics, making this remotely accessible. And we see still an enormous uptick in GPU acceleration and VDI in general. And of course, this has lots of, well, organizations start to adopting VDI or server-based computing due to this global pandemic. However, the collaboration is something that will be, even without a pandemic, will be very important, of course. And providing people the mobility to work wherever they want to work with the tools they need. Still, these are valid reasons, also post-COVID, if that's ever gonna exist. But still, these are key drivers. Gartner did some research here, and as you can see here, well, 48% of the employees will likely work remotely at least part of the time, even after this C-19 pandemic. So it's very important to be ready for that. And why we do this virtualization and GPU acceleration in the data center, this is what people expect. This is what an employee within an organization kind of expect. He or she works with GPU accelerated products in their consumer life, but at least in the physical world from well, each and every day. So why not also accelerate the workloads in the data center? So this is what we do with vGPU. We take a physical GPU, carve it up, and assign different portions of pre-configured profile types, basically frame buffer types, to virtual machines. And this allows multiple virtual machines to have access to the same GPU acceleration at the same time. And due to the fact that we need to install a Nvidia virtualization software layer in the hypervisor, and also, of course, the drivers within the guest operating systems, Linux or Windows, this allows us to have some more insights on performance, application monitoring, session monitoring, etc. So it also increases the amount of manageability, or the manageability will be increased with the vGPU solution. So for vGPU, the current GPU hardware lineup looks like this. Still, we have today the Maxwell M10 available for the the financially optimized, but also for the user density use case. But I would always recommend you to choose the Nvidia T4 or multiple T4s over a single M10, due to the fact that the M10 is an older GPU generation that doesn't do any VP9 encoding or decoding, and especially decoding is important there due to YouTube, for example. And no H.265 video decoder available. There is a hardware limit of system memory, so there are some cautions with the M10. And if we move up towards more the performance optimized solutions, we have the A40 or maybe the RTX 6000, but that's based on an older generation, of course. And for those use cases where you need to do vGPU for an AI type workload, so you do want to use the flexibility that virtualization has to offer, we advise you to take a better look at the A100 or maybe the V100. So again, this is a familiar slide for those who have seen these sessions before. Keep in mind M10 T4. Whenever you're more towards the density optimized, the T4 or the RTX 8 or 6000 when it's more towards the performance optimized environments, and of course the A40, and for the V100 and the A100, that's more towards the high performance compute AI type workloads. And one very important part here is the third row from the top. So the virtual GPU software product. The A100, due to the fact that there are no encoders, it's only supported with virtual compute server. And the same applies to the M10, which is not available for virtual compute server, but only for the more graphics accelerated use cases. So just to simplify this, knowledge worker T4, the more demanding use cases T4 or A40. And whenever you're pursuing a deep learning, machine learning, HPC type workload, the A100 or maybe multiple T4s. There's one thing that I forgot to mention, maybe on the previous slide. If you look at the A40, and the same applies also to the Rtx A6000, this is a board that supports 48 gigabytes of frame buffer. So the smallest vGPU profile with virtual PC, for example, is 1 gigabyte. So you would assume that you can run 48 simultaneous sessions on a A40 or an Rtx A6000. Well, this is not the case. So we have limited this to 32. So maximum is 32 concurrent user sessions on a GPU with more than 32 gigabytes of frame buffer. And this all has to do with protecting a GPU for congestion or over commit of resources that is required by all the virtual machines. So you could assume, of course, when you're running 48 simultaneous sessions on a single GPU, so all the CUDA cores, for example, you will get a time slice, and this is, well, probably not leading to the best user experience. So 32 is the limit there. Keep that in mind whenever you do the sizing, and also keep in mind, as it says here, the A40 is more towards the performance optimized solution. So yes, you could do 1 gigabytes of frame buffer, but usually in a performance optimized environment, you would go to 3, 4, maybe more gigabytes of frame buffer. So whenever you're using a 1 gigabyte GPU, vGPU profile, I think the T4 is a better solution because you get more cores, of course, in the end. As I said, data center and cloud solutions. So today, of course, with many of the hyperscalers or smaller cloud offerings, we have lots of opportunities to use GPU accelerated resources with different remoting stacks, with different physical endpoints. And we provide lots and lots of flexibility when it comes to licensing, for example. A customer can either choose to bring their own license, and of course, a partner of us, such as you, maybe you can also leverage this on based on a CSP model. And there's also like desktop as a service managed offerings. The Azure Marketplace, for example, has the RTX virtual workstation available, including a license, including the RTX certification. So this is also an easy way to consume GPU accelerated resources. Talking about vGPU and the license types that we provide there. Again, for those who are familiar with vGPU, we have 4 types of licenses: the virtual apps, the virtual PC, and I see there's the old name still in this slide. So the RTX virtual workstation should be the third one from the left. These are all accelerated graphics focused GPU license types. And then all the way to the right, we have the virtual compute server license. And this is a license focusing on HPC or AI type workloads. So empowering your data scientists within an organization to have GPU accelerated resources. This is also the only license that is a per physical GPU license type, as where virtual apps and virtual PC and the RTX virtual workstations are a per concurrent user license type. I want to briefly highlight the RTX virtual workstation and the virtual compute server opportunities that we have. With RTX virtual workstation, well, you can serve a variety of use cases, of course, the 3D acceleration, but also to the left, we see Omniverse and CloudXR. And just to highlight the Omniverse, what we can do with Nvidia Omniverse is live collaboration with applications in order to provide end users from across the globe to work simultaneously on the same platform. We could do simulation, we could do rendering, so you can create your own rendering or rendering viewport with multiple applications. And this is extremely important in different use cases or industries. If we take especially AEC, architecture, engineering, and construction, for example, we see the processes being conducted there, the iterations when someone needs to come up with an idea, it needs to be drawn, and then it goes back. Is this what we need? Someone else needs to like visualize a building, that you need to work with the lighting, that you need to work with the interior, so all the props need to be sent in. And also in media and entertainment, this is also very important there. So what we have done here is create like the Google Docs platform for the 3D workloads, and this looks well, with the different components that we've created in Omniverse, it looks like this basically. You create one nucleus machine. This can be a virtual machine or on a physical implementation. And this is like the central heart of your Omniverse environment. So this is basically the hub, the Google Docs, where all the different applications can connect into. So we have different connectors for different applications that connect to this nucleus virtual machine. And then we have Kit, and that's basically like a big toolkit of all kinds of SDKs, where we provide like our own tools as well, like RTX ray tracing, like physics. This is where you can basically build your own connector as well, but also where the intelligence of the application is. And as I said, then you have the simulation, like for robotics, for example. Keep a close eye on the GTC sessions with BMW. So we kind of simulated, not kind of, we did simulate an entire factory of BMW where they could do like process planning and optimization, etc. And there's also the RTX renderer, so like a viewport. So in the end, what it does, what's the benefit for an end user in an organization is, well, this use case, for example, is where someone is using different tools like 3ds Max, Maya, SketchUp, Substance. Well, you can see all the logos there, but on a single workstation. But whenever she, in this example, needs to create something in 3ds Max and then send it over to Maya, maybe that's an easy example, but maybe bring it to Revit, you need to export it, import it, etc. And what we do with Omniverse is connect this all to the centralized nucleus virtual machine or a physical server, and you would instantaneously get to view your end result. But of course, if you would do this with multiple people across the globe, all working the same in the same object, in the same project, this would really help, right? So here you have like, I don't know, maybe one person in Munich working with Unreal Engine 4, someone in Hong Kong working with Substance Painter, and maybe someone in Santa Clara is working with Maya. And with this RTX renderer at the top, you would see one example, one real-time ray traced image, where both someone is working in those three applications. So 3 individuals all working together. So real live collaboration for these examples. The other topic that I want to bring up for the RTX Virtual Workstation is CloudXR. So basically what we do with CloudXR is take an Nvidia Ai environment as an example. You would remote you would remote into an application. But what if this application is a virtual reality or an augmented reality application? And you would simply stream this over to a head-mounted display, an HMD that someone is wearing over a 5G or a Wi-Fi tethered environment. So again, here you would see in different verticals, in different industries, really the benefit of any form of extended reality that can help, whether that's entertainment or in healthcare, for example. So what we have done is basically we created this VR or AR streamer, which can be streamed to different devices. And as I said, whether that's 5G, Ethernet, or Wi-Fi, this all, of course, helps. Especially the head-mounted display that do not require any wires to a physical workstation. Those people can really benefit from CloudXR, as you can understand. Next to the RTX Virtual Workstation, I wanted to briefly highlight the Nvidia Virtual Compute Server license version. Remember, this is the license that is per physical GPU. And this is specifically designed for HPC, machine learning, deep learning type use cases. So we both support the A100 as well as the A40 in these use cases. With the A100, of course, you have the multi-instance GPU technology. So you can slice up a physical A100 into 7, that's the maximum, into 7 GPU instances and do different inferencing or jobs, or maybe assign different GPU instances to different training tasks. So this allows you to get like a heterogeneous environment, and we also provide the GPU direct and GPU operator, which are available also in the Nvidia Ai Enterprise. But this is something that we'll cover later on. And of course, for those people who have been working with HPC over the last couple of decades, it's always been around getting as much as performance out of a configuration. And of course, bare metal always is slightly better compared to a virtualized environment. However, you do not have the flexibility or the live migration, for example, or the monitoring part. So I truly believe that the world of high performance computing and AI type workloads is going to change over the next, well, hopefully a couple of months, but especially over the couple of years that we're facing. HPC will make its way towards the data center. And I think when we look at AI, for those organizations that work with like the development phase where you do training with a subset of the data, it really can make sense to start on a virtualized environment in these use cases. So very important to understand what kind of opportunities there are available with vGPU, as many organizations use this already today. A little bit about the latest on vGPU 12. So that's the latest version. Last month we released the 12.1 version. And there are, again, also here a couple of changes. So as you recognize on this slide, we dropped the grid name. So where we initially introduced the solution in 2013 as NVIDIA Grid, we're now pivoting away towards the NVIDIA Virtual PC and Virtual Applications, so VPC and VApps. And both the Quadro Virtual Data Center Workstation as well as the Nvidia Quadro Virtual Workstation, which is available in the Azure Marketplace, those two will be both renamed into Nvidia Rtx Virtual Workstation, so VWS. What we also introduced with version 12 was support for the A40 and the GPU operator and the virtual compute server. And especially the, I'll cover that later. So with the A40, kind of similar as to the Rtx A6000, the difference is, of course, that the A40 is specifically designed to be used in the data center, so passively cooled. The board, however, does have 3 display outputs. So technically, you would be able to connect 3 displays to it. However, these display ports are not enabled by default. So in order to enable those, you need to request access via NDA to a tool, the display mode selector tool. But I always advise you to double check before you purchase or suggest this to a customer to really make sure whether the A40 is the board or the Rtx A6000. The simple thing is, whenever you are using it for virtualization or just compute in the data center, the A40 is the one. Whenever you need a GPU or you need to physically connect displays, the Rtx A6000 is the one you need to choose. So try to avoid this mode utility as much as possible, because effectively you would have the risk to break the board. So don't do that. The A40, well, it outperforms when it comes to graphics the Rtx 6000, as you can see here on the slides. What we do, of course, with SpecView Perf 2020, and also when it comes to rendering, it even 2 times faster as the Rtx 6000. So as I mentioned, both boards are more or less the same, more or less similar. They both support NVIDIA vGPU. However, if you want to do vGPU, you choose the A40. If you just physically want to connect the displays to a machine, use the Rtx A6000. And as I said, try to avoid the utility to change the mode of these boards as much as possible. Another thing that we introduced was the GPU operator, and the GPU operator has to has everything to do when it comes to Kubernetes, for example. The GPU operator, well, it basically simplifies both the initial deployment and management of the components by containerizing all these components and using standard Kubernetes APIs for automation and managing these components, including versioning and all the graphics as you progress along the way. And this is fully open source, so it really ties into the open source concept that many organizations already have in this field. And then one thing that I want to shout out here is maybe some of you have seen this. We have the Nvidia Certified program, so where we certify hardware. This is both for our Nvidia Certified or EGX platform and also for the HTX platform. And what we have done, we kind of tested and optimized the entire stack. So for GPUs, for networking, and also the Bluefield or the ConnectX-6 interconnects that you use in a platform. And on top of that, we have the Nvidia GPU Cloud, where you can easily consume any framework, pre-trained models, Helm charts. So everything that a data scientist or researcher in an organization is using today can now be done on a completely certified stack when it comes to hardware. So of course, as I said at the beginning, in this software-defined world, it's very important to have an entire stack. So what we have done based on Nvidia Certified, together with VMware, we now have the Nvidia Ai Enterprise program. So together with VMware, vSphere 7 Update 2, with VMware Tanzu, VMware Cloud Foundation, you more or less have all the building blocks to start using the Nvidia Ai Enterprise solution, which again, this allows you access to everything that is available on Nvidia GPU Cloud, and just consume this. So a data scientist, he or she, whenever she need to build up a AI stack, there's a lot of like shadow AI or shadow IT maybe, where a data scientist, well, kind of depends on its own, needs to build up the entire stack, puts all the firmware together, the software together, the right versions, the optimizations, etc., and just plow himself through 200 pages of documentation. And after a week or 2 weeks, you have one configuration for one particular framework in a particular version. So what we do with the entire, well, commoditizing or democratizing in AI is, together with VMware, a data scientist can simply request a virtual machine with a Linux distribution running on it, all the right software versions, and he or she can immediately start pulling a Docker container from Nvidia GPU Cloud and can start training. If it's not good, you need a different version. Okay, just pull a different Docker container. So this really helps organizations to bring those data scientists that are like little hidden gems in your organization, make them seduce them to use the centralized and virtualized environments that you have already available in most of the cases. So Nvidia Ai Enterprise, keep an eye out to that. It includes GPU operator, the network operator, GPU, a vGPU, and everything that you would need in order to get a AI type, HPC machine learning type workload up and running quickly. Looking at the time, so 10 minutes left. I've got a couple of tips and reminders. Keep in mind, the Ampere GPUs provide also now the AV1 decoding capabilities. So as I mentioned, like VP9, H264, 265, these are all different codecs. VP9 is a codec that YouTube used to use. So whenever you're using like a Chrome browser and you're watching a YouTube video, chances are that you are, well, very high chances that you were using a VP9 codec. Now YouTube is pivoting towards AV1. So Ampere provides AV1 decoding capabilities. Whenever you're running vGPU 12 on ESXX7, make sure to apply the right patching. I've mentioned this throughout the session. So with any GPU with 32 gigabytes or more, so the RTX 8000, the A40, and the RTX A6000, there is a hard limit of 32 sessions, and even with 32 times 1 gigabyte vGPU profiles, make sure that you still test this. So again, I would really urge you to use 2 T4s instead of one of those boards that are listed here, whenever you're using a 1B or a 1Q profile. There's a nice sizing guide available for Citrix Virtual Apps on ESXi. The link is in here, so use it as you like. And also for Virtual PC, a sizing guideline. Very, very interesting read, especially if you are working on such projects, of course. And if you are working on those projects, you need to provide the answer to yourself or to the customer, how much vGPU frame buffer do I need to assign to a single virtual machine? Make sure that you measure both before, during, and also after a POC. And to do so, you can use a GPU profiler from our colleague Jeremy Main. Also, make sure to always check your hardware configuration against the qualified server catalog. There's also now a column listed for the Nvidia certified or NGC ready. And whenever you're also using a server solution for vGPU, then also make sure that it's on the vGPU certified catalog or server catalog. And one final one, vGPU trial or evaluation licenses can be requested for free. Always make sure that whenever you're requesting such a license, to use the company details of the actual end customer. And the reason is whenever the licenses are granted, this will be automatically connected to the enterprise account of this customer. Then you need to set up the licensing server for that customer. And whenever it's tied to your organization as a partner, that will be, well, challenging when you need to hand over the project, of course. And just to finalize this, I think the majority, and this is also where our partner level landscape started, the majority is with virtualization for graphics use cases. But since we introduced this virtual compute server license, there is a huge opportunity for each and every virtualization expert partner out there to go out and seek these other opportunities in organizations for machine learning, deep learning, or high performance computing. So in the end, it's just another app. And yes, you would need to understand the application or the workflows. However, nothing stops us from talking to data scientists or researchers in an organization. What is it that you need? Can I help you with providing access to a Linux virtual machine with GPU acceleration, providing you access to Nvidia GPU Cloud, and that you can start training with a prototype network right from the start. Feel free to use that as you like. And before I go over to the quiz, quick reminder: Nvidia GPU Technology Conference, GPU Genius, is something that you would go to as a partner to get trained. Well, you're more than welcome to join us starting on April 12th and browse the session catalog before that in order to see if you can find any interesting sessions. The only, well, a challenge today is there is so much good stuff. So maybe you would feel yourself a little bit overwhelmed by all the resources that are available. As I said, feel free to reach out for any questions. By email is always the best option, I guess. And
if I can interrupt you,
yeah.
2 seconds.
Yes.
We have a question in the chat, but I'll let you read it directly, because otherwise I will probably make a mistake.
Okay. Yeah, I was looking at the wrong chat, I saw. So no.
Do you have it?
Wait. Oh, sorry. No, I was looking at the right chat.
So we have a question
how
from,
would VR AR with VDI work regarding to frames per second? To have a good experience, you need 90 frames per second for a smooth experience, but most VDI do not provide these kinds of numbers. Well, Michael, you're exactly spot on. You need at least 90 frames per second, otherwise you get motion sickness. And this is due to the reason, of course, you need, well, you have two eyes, so you would have two displays. Ultimately, you would have like 60 frames per second per eye, so 120 frames per second. This is what we support. Today, both Citrix as well as VMware do not support. Their limit is like 60 frames per second. And this is exactly why we introduced the CloudXR. So CloudXR is like where you can compare this to a VDI, but this is not like based on your typical VDI environment with Citrix or VMware. So you would install a server component, the CloudXR server, and also a CloudXR client component. And this takes care of the streaming process of the VR or AR images. And this is where we can go up to 120 frames per second. But if you, and maybe I was, it was a little bit confusing there. When I talked about the VDI type solution for extended reality, basically on the left side, where is it? Like here, there's no like a Citrix or VMware environment. There's the CloudXR environment that takes care of the streaming and where we can provide the 90 frames per second or even 120 frames per second. So yeah, good question. And I can see you typing, but I'll start preparing for the quiz if that's okay. Because as I promised, I would start off with a little quiz. So if you go to Kahoot, Kahoot.it, or use the Kahoot application on your mobile phone. Let me see if I can do it like this. There you can type in the pin code 747-9880, and I can see Stijn is already joining. So yeah, I always advise you to use a name that we can recognize, because if you're one of the lucky ones that wins a prize, and it's easier to contact you to get some shipping details, of course. So let's see. So all feel welcome to join, or feel free, I must say. And also keep in mind, when we do this little quiz, the faster you provide the correct answer, the more points that you get. So it's not only about the correct answer, but also how fast you are. Some questions will be like true or false, and there are also some quiz questions. So where you get a question or a statement, and where you can provide 1, 2, 3, or 4 correct answers. So this can be just 1 out of 4 or 4 out of 4. So just to keep us all on our toes, and it's only 6 questions. So let me see. I'll get started before people need to drop. So the first question, we could start it. Let's see, a true or false question. The Nvidia A100 in a vGPU scenario only supports virtual compute server. Is this true or is this false? And remember, A100, no decoding. So only, no encoding. Almost made that mistake. So we only do decoding. This is true, exactly. It's only supported in a virtual compute server scenario. So let's see who is on top. So Michael is there, followed by Chris, and then Stijn. But we have still 5 questions to go. So still plenty of chance for others to catch them. Advantages of Nvidia Omniverse are, and this is one of those questions where you can provide multiple answers. Choose red if you think one of the advantages is to accelerate the designing process. Is it an advantage that everyone works with its own data set? Is it an advantage that you can do both visualization as well as simulation with Omniverse? Or is the live collaboration with different applications? And as you can see here, the only incorrect answer was everyone has its own data set. Of course, the the added value is, like, as I mentioned, the Google Docs, everyone works with the same data set simultaneously. So that really helps, of course, with the live collaboration and also different iterations in the design process. Let's see. Michael has dropped to place number 4, and Chris has taken over the lead. But still, we have 4 questions to go. So let's see what's going to happen. Nvidia Ai Enterprise is, and again, multiple answers maybe, supporting Nvidia vGPU. You do vGPU with Nvidia Ai Enterprise. It provides access to AI and data science apps and frameworks, leveraging Nvidia certified hardware, so the Nvidia certified program. Or is it optimized and certified and supported? Yes, all answers are correct. Let's see what we can do with the ranking today. So Stijn, he's on fire. 3 questions in a row that you did completely correct. So question number 4, the Nvidia Rtx A6000 and the Nvidia A40 both serve the same use cases. Is this true or is this false? Both boards are kind of similar, but as you can see, of course, actively cooled versus passively cooled. But they do not really serve the same use cases ideally. As mentioned, physical workstations, A6000, virtualization, data center centralization, you would use the A40. And now Chris is on fire. Well, he's a friend of the show, so maybe he recognizes some of the questions, but always good to see someone answering all the questions correctly. So Chris, Marco, and Michael, let's see if we go when we go to the 5th question. Which are correct vGPU license types? And remember, there are some changes when it comes to naming. Is NVIDIA Virtual PC correct? NVIDIA RTX Virtual Workstation correct? NVIDIA Grid Virtual PC or NVIDIA Virtual Compute Server? And as you can see, there's no Quadro Virtual Data Center Workstation license anymore. And also we dropped the name Grid. So there's more focus on the brand name NVIDIA. So everyone, no one did mention the Grid Virtual PC license. So let's see. Well, a minor shift. Michael has overtook Marco and is now second. And let's see, but he is really close, right? It's only 7 points behind Chris. And when we go to the final question, and thank you for staying on 4 minutes over time. Arrow is an NVIDIA distributor for NVIDIA vGPU, NVIDIA Quadro / RTX GPUs, so the physical workstation GPUs, the data center GPUs, and also a distributor for DGX. So let's see. That's correct. That's correct. So the one-stop shop for you as a partner to get everything. So let's see the final score. The 3rd place, Marco, congratulations. And 2nd, Michael, congratulations, Michael. And there we have on the highest level, Chris, congratulations. I'll reach out to the 3 of you and also the runners-up, Stijn and Erik. Congratulations. I will follow up and reach out in order to get your details, and I will make sure that some nice prizes will be shipped